Hi everyone, David Maley here. Today what I'm going to do is we're going to build a predictive model, and I'm going to take you and walk you through this with using R and Rattle. So Rattle is a graphic user interface that you can bring up through R, and right behind this window is this other window which shows you the commands to bring it in. You've got library, Rattle, you bring this in, once you've loaded it in your computer under R, and then you run it with Rattle with the open and close parentheses. And that brings up this. Now inside this you'll notice I have a comma delimited file named day.csv. Now this file you can get on the internet, and it's very easy to get any kind of file you want, any data set you want, you can put in here. And so I've already put in here, and if you look in here I've changed a couple things. I've made count be my target. It already actually is season, but I'm going to change it to count. I'm going to make the two fields of casual and registered, I'm going to put them to ignore because they equal count, so you don't need that. And I'm also going to ignore DTE day, or date today. So I'm going to take this, I'm going to execute it, and you're going to see now the regression models are enabled. I could run regression if I want. I did that in another video where you can see that. And so what I'm going to do in this video is I'm going to run a model, a linear model, just the way it is. So let's go up here, see where the tab says model, and I have a choice of all these different models. I can have tree, forest, neural net, linear, and we'll compare them in a little bit here anyway. So let's just go to linear. So we're going to do that, and then we want to make sure that it's numeric is checked, and that's all we want right now for this. We're not going to do anything else to this one, so let's just run it as is. So we're going to hit execute right here, and here's our data with the with that run just as is on a linear regression model. And right now we're looking at a adjusted R squared of 0.8092. That equates to a accuracy of around 80%, give or take a little bit, and we'll see that in a minute. Okay, and there's ways to improve this. So I could take this and maybe get this up a little bit by exploring and opening up, or some people call it exploding, some of these variables. So these variables over here, like season, year, month, holiday, weekday, working day, weather set, temp, atemp, all these can be expanded upon. So for instance, month, you have 12 months in a year. You have January, February, March, April, May, and so on and so forth. You can take seasons, holidays, weekdays. You have 7 days of the week. We can expand that out. So that's how you can improve upon these other model like this. You can also run, if you wanted to, these other ones and compare them. So basically what you want to do is you want to get this, and there's ways of getting that higher. So what we want to do is we want to run what's called a predicted versus observed plot. And I'm trying to remember where I have this. It should be under here. Here it is. So we take this evaluate right here, and it's right here under this. And let's see, we want to have validation, linear. Okay, let's run it as is. And there we go. So actually, when you look at this, our squared pseudo value, or pseudo R square, is 0.7125. And that actually ends up being the percentage would be correct. So if you took a straight outward guess, you're at 50%. An educated guess might be a little better than that, but not much. What this is saying is that if we use this model that we have right here, that we built this off, as is, we have a 71%. So for instance, let's go back here and bring this back up again. Here's our Rattle command post here. And what we can do is we can look at season, and let's see here. Where is season on this? Let's go to data. Okay, so you can see here, here's our actual field names. Okay, and what we can do is we can go to let's see here, transform. We can go to recode, and what we can do is we can take, let's say I want to take season, And season, we can see right here, it has 4 unique values to it, right? So you got the season of fall, spring, winter, and summer. So what we can do is we can expand upon that, and we can make that so it shows all 4 instead under flags. So what we'll do here is I'm going to take season, and I'm going to make it first as categoric. So we got that on there, and we hit execute. Watch what happens. We now have one new variable that is season, and it's categorical, and it's got 4 levels to it. Now what we want to do is we want to take this and we want to expand that. So we're going to recode that as an indicator variable. This one here, not the season one, now the new season one, which has 4 levels to it. We're going to take that, and that one, this one here is categorical. We're going to make an indicator variable for these. So watch. Now we hit execute, and you see how it expanded? Now we have 4 here. So what that means is you've got 4 flags for each one. For instance, if it's spring, summer, winter, whatever, it expands it out. So now if we go back out to data, we still have those in there. See them right here? But they're not in the actual running of this model. So we have to include them in this model. And that just gives us more instances of, well, what if it's this and this? What if it's month and season of spring? So, and it combines it better that way. So let's say execute. And we've got regression models enabled, to target is count, and we've got these added. And the top one here is ignored, okay? But these guys, because that's just categoric, that doesn't really tell you anything. But the bottom ones here have to be input, because you want to have input for them. So now if we take that this way and we execute it again, okay, now we have all the correct features to it. So now what we want to do is run that same model again, watch and see if this number changes. Okay, so if we go to model, go to linear, leave this numeric, leave it the way it is. Now what we're going to do is run it. And now let's go back down, and let's see. Now remember before it was 0.82, now it's 0.8302. So we've improved by 1.5 points, something like that. So if you go into our evaluate, we go back to the PRVOB validation, we run this again. Remember it was 0.7125, so it ends up being 71.25% accuracy. Let's run it again, and we're at 0.74. So we had an improvement of almost 3 percentage points just by expanding out the seasons. Now we can also go back and do this again if we wanted to. So if we go back to our model, and we can look at our model here, this is what we expanded upon. We've also got in here other variables that we can use. What you want is a variable that has a linear relationship of some sort. So, and some will work better than others. So you have holidays, you have weekdays, working days. What you'll do is go back here to data, and what we're going to do is look in this list, and we want to see these unique values here. Like this one has 4 unique values. It's very hard to split out and explode to something that has 499 or 690 values. That will increase in some cases your level of confidence and accuracy, but at the same time it will also greatly increase the amount of variables you have and make it very confusing too. So let's go up here and see what else we have. We have weekday. We could expand upon weekday. We could also expand upon month. So if we expanded upon month, we could try that. Let's try that one. So if we took month, we went to transform, again recode, so we're going to recode this, and we want to have as categoric. We would take month, which has 12 unique values, so we're looking at January, February, March, April, May, and so on. And what you want to do is the first one has to be categoric, so you hit execute under here, and that gives us the month as the categorical field. Now what we got to do is recode indicator variable, and we're going to hit this one for it, hit execute, same thing. Now you'll see we have 12 new variables here. We have to go back to data, back to this. Remember the first one is ignored, automatically set to ignore, which is fine. The rest of them have to all be brought back in, just like this. And they're put as input fields. Then we have to run this model again. Okay, and it shows us how many observations, input variables. Now it's up to 25 input variables because some of them are ignored. Regression model is enabled. Okay, and next we're going to go back to our model, and what we're going to do is the same thing, linear. Okay, and we're going to run it. And let's see what that did. So we were at 0.84 last time. I think we're about the same. Let's go to, so that really may not have done much there. So if you go back to evaluate, PRVOB, validation, let's, linear is checked, execute. Oh, we did go up. We went up, actually, we were at 0.74, we're now at 0.77, so we did go up. We went up, now we're at a 77.39, basically 77.4% accuracy, which is a big increase from where we were. Now we can go back and keep doing this, so you can look here and find other fields up here of our original fields that we could expand upon, like holidays. Either it is or it isn't. You have two unique fields there. Would that hold something? You have to see if it's linear or not in relationship, but we could do that. We could take holiday and go back out to our model and go to transform, and we could hit holiday, which is right here, and it's 0 to 1, 2 unique, so we can go here, go to recode, let's see, as categoric, and we hit execute on that. It gives us a new holiday right here, and then we take that and make that an indicator variable. Everything else stays the same. Hit execute. We get 2 new variables for that. Now go back to data. Same thing again. We're going to go and make these 2 inputs, the 2 new input, or off based off the categoric. The categoric stays ignore. Hit execute. Now remember where we were. 77.39. So now let's go back to our model, go back to linear, and let's execute it. So let's go here, and what do we have? Did that help us in any way, shape, or form? I don't think it did at all. It's 0.8484, so there's really no linear relationship there that's usable for just that one holiday field. And if we go to evaluate, predicted over here, PRVOB, and we've got linear check. Let's hit this, exact same value. So the holiday one really wasn't worth doing. You may be able to find a couple more in here that have a linear relationship that you might be able to benefit from, but this is how you, so we've already built the model. Now we're just improving upon the model. We've already improved it from 0.71 to 0.7739% accuracy, which is, 6 points is a huge increase. I mean, especially depending on the niche you're in, like grocery, software sales, a small, even a 1% gain in accuracy is huge across the board. And this is the stuff that executives like to see. So if we go back here, I could go back here and I could do this quite a bit. There's still some that I could use, working day, maybe weekday. We could try that if we wanted to, and try and crank that up into the 80% of accuracy. You keep doing this, you can do that. Now we can also go into the models and compare. So our model has 0.7739 and 0.8484 for the adjusted R squared value. So if we went up here, I could go and try a neural net and execute that and see what that does. We can go down here and find our squared value. If we want, we can also go and go to evaluate linear. So this will compare our linear, which you can see behind here, and it'll compare the neural net. So we can execute that. And let's see here. Here's the comparison. Well, let's see. It's not showing the comparison, but let's see. Yep, here it is. Versus the neural net. And we have to probably make this bigger so it shows. Well, there you can see it anyway. So what you've got is they're very close. The linear fit is right here, predicted versus observed. And let's see, where's the other part here? There we go. Oh. So you can go and compare. You can compare many different ones of these to each other, and it's pretty interesting stuff what you can do here. So what I've done is I've improved this from 0.71% to 0.7739%. That's a big gain. We could do this with several more. Then we'll probably get that up into the 80 percentile range, maybe 82%, 83%. And then there's other ways of changing these things too, besides that, using some formulas, making some special variables, things like that. But this gets you pretty far along if you're doing data science. You're doing a full workout. I've got a video out there on how to do linear regression or correlations and correlation analysis. I've got ones out there on doing exploratory data analysis, all kinds of great videos. You put these together and you can do a full entire data science workout and impress your boss, impress your coworkers, and learn how to do predictive analytics. This is how it's done. And then you just take your data set, your model that you've created, and plug in other data into it, and you can show, hey, because I've got an 83% accuracy ratio, here's what we can do with this data, and this is what the prediction looks like. And you can learn some great stuff from this. I'm going to do a lot of great videos like this to show you and take you further into data science and exploratory predictives and predictive analytics. Well, thanks for watching. Please take a moment to subscribe down below and like, and please leave me a comment. I'd love to hear from my viewers and my subscribers. Thanks again, and have a great day.